In this lesson, you'll learn to find limits numerically and using tables, and learn how to find limits graphically. So Unit 1, limit and continuity, and one, find the limit graphically and numerically. We have the graph of function f of x is equal to x squared minus 9 over x minus 3, x minus 3. As you can tell, we can plug in any value of x except for 3, because if I were to plug in a 3, I would get a 0 in the denominator. Denominator equals 0. So undefined value. So it's not clear what the graph would do when x is equal to 3. To get an idea of the behavior of the graph of f when it gets closer and closer to 3, we're going to use a table of values. So we're going to look at x values from two different directions. In one direction, we're going to look at the value of a function as approaches 3 from the left side. And also, what's the value of the function as x approaches 3 from the right side? So let's go ahead and make a table of values. I'm going to place 3 right in the center. And once again, I cannot evaluate the function for x is equal to 3 because I would get an undefined value. So now as x approaches 3 from the left, we can let x equals 2.9. Now, if I find f of 2.9, if I plug in a 2.9 into our function, we get 5.9. Now, if I let x equal 2.99. So once again, you're getting closer and closer to 3. We get 5.99. Now, to get even closer to 3, we can let x equals 2. Wait, sorry. Oh my God. 2.999. And if we evaluate the function for x equals 2.999, we get 5999. And once again, there is no f of 3. Now look from the right side. That's x equals 3.001, 0.01, 0.1. The value of the function at these three values is 6.001, 6.01, 6.1. So it's quite clear from this table that as x approaches 3 from both directions, the value of the function is getting closer and closer to 6. Now let's look at this graph. X and y. Okay. When you graph the function, the graph of x is a straight line, and that has a gap when x is equal to 3. Once again, why do we have a gap? Because if I plug in a 3 into our function, we're gonna define the solution. But as we get closer and closer to 3 from both directions, the value of our function is getting closer and closer to 6. This is an introduction of the limit, which is a very important topic in calculus. So we can write the limit as x approaches 3 of f of x is equals to 6. So we can say the value of the function is 6, but we can say that the limit as x approaches 3 of f of x is equal to 6. So a limit means that if f of x becomes really, really close to a single number, let's call it L. As x approaches a constant c from either side, then we say the limit of f of x as x approaches c is equal to L. So the general form is the limit as x approaches to c of f of x is equal to some number L. In this problem, we want to find the limit of the function x to the fourth power minus 16 over x minus 2 as x approaches 2. X to the fourth power minus 16 over x minus 2 as x approaches 2. Now, once again, we're going to find the limit because if I were to try to evaluate this function at x equals 2, I would get a 0 in the denominator. So we want to find the value of the function as we get really, really, really close to x is equal to 2. So what we are going to do is we are going to set up the table of value. And 2 is what we want to approach. So I'm going to put 2 in the center. Okay. So we're going to pick some points that are below 2 and some points that are right above 2. But we want to get really, really close to 2. So I'm going to pick 1.9, 1.99, and 1.999. So I'm getting closer and closer to 2. And the numbers that are above 2, I'm going to pick 2.001, 2.01, 2.1. So what we're going to do is we're going to evaluate the value of the function at these 6 points, and you can use your calculator to do that. So the value of the function when x is 1.9 is 29.679. We get 31.760799. We get 31.976007999. And we get 32.024, 32.24, and 34.481. So as we get closer and closer to 2, what's the value of the function approaching? Well, I could see that I'm gonna higher and higher to 32. And in this case, I'm also getting closer and closer to 32 as my x value is getting closer to 2. So we can say that the limit as x approaches 2 of x to the fourth power minus 16 over x minus 2 is equal to 32. Now we can verify the limit from the graph. Here's a graph of the x to the fourth power minus 16 over x minus 2. As you can see that when x is equal to 2, there is a hole because I cannot plug in a 2 into the function. But as you can see from the graph, as we get really close to 2, the value of the function is getting really close to 32. Now it's your turn.